Name each operation or property used to justify each step. So here we go. You always start with what you're given. You always write down the original problem. So I've written the original problem, and this was simply given to me. Why am I allowed to say this statement? Well, that's what was given. Simple as that. What I'm going to do is I'm going to first subtract 9 on both sides of the equation. That's going to leave me with 4x is equal to 9 minus 1/2 x. Now, what allows me to subtract the same value from both sides of the equation? The justification, or the property that allows me to do that, is the subtraction property of equality. Alright, the next step, I'm going to go ahead and add 1/2 x to both sides. I'm going to change, I know it's 4 and 1/2. Okay, 4x plus 1/2 x is 4 and 1/2 x. I get that, but I'm going to change it into an improper fraction because I do not like mixed numbers and I do not want you to write mixed numbers. So this is going to be 9/2 x. I want to use improper fractions. So what allows me to say this? How do I know that if I add 1/2 x to both sides that it'll still be a true statement? What allows me to add the same thing on both sides? Well, that's the addition property of equality. The justification that goes along with the step or with the statement, that is, how did you get here? Like, what did you do to get here, and what allows you to get here? So I understand that I'm not about to add anything, but I did add 1/2 x to both sides to get here. So that goes with this statement. That's what I did. Next thing I'm going to do is divide by 9/2 on both sides of the equation. So I'm going to get x is equal to 2. So how did I get to this statement, that the fact that x is equal to 2? Well, I divided by 9/2 on both sides. What allows me to divide both sides of the equation by the same value? Well, that's the division property of equality. And there you have it. We have solved and we have justified every single step. We were given this equation. I subtracted 9, and I'm allowed to do that because of the subtraction property of equality. I added 1/2 x to both sides. I'm allowed to do that because of the addition property of equality. I divided by 9/2, and I got here, and I'm allowed to do that because of the division property of equality. And I am done. X is equal to 2. Now, let's get a little bit more formal with it. It says, you can organize the steps and the reasons used to justify the steps in 2 columns with statements, or the steps, on the left, and reasons, the properties, on the right. This format is called a 2-column proof. So I've mentioned this before in class. I actually did a 2-column proof for you when I justified and proved that vertical angles have the same measure. So you've seen this before in class, but this is where we're truly introducing it. When you come into class, be sure that you ask any and all questions regarding the format of a 2-column proof and how 2-column proofs works. Hopefully I'm about to answer some of those questions. So here we go. We're given an example that's all filled out. So we look at example A together. We are given this statement, this equation, that 3 times the quantity x plus 2 is equal, 3 times the quantity x plus 2 minus 1 is equal to 5x plus 11. The first step in a 2-column proof will always be what you are given. You always start with what you are given. And then from there, you work down to some goal. In this proof, our goal, what we're trying to show or what we're trying to prove, is that x is equal to -3. This is called the prove statement. The prove statement, so it's going to go under statements, will always be the very last statement. So you always begin with what you're given. That'll always be your first statement, and your first reason will always be, this is my given information. So always start with your given. And then you're going to work, and justify until you finally reach to your prove statement, in this case, which is x is equal to negative 3. And making sure that you just justify each step all the way down. So let's look at what they did. So from step 1 to step 2, they added 1 on both sides of the equation. And they got this new equation that reads 3 times the quantity x plus 2 is equal to 5x plus 12. What allows them to get here? Well, they just added 1 on both sides of the equation. Well, what allows them to add whatever they want on both sides of the equation and it still be a true statement? How do we know that? Well, it's the addition property of equality. And we don't need to prove this property. We know it's true. We know it works. So what did they do after that? Statement 3. They took this 3 that was outside of the parentheses and multiplied it to x, and they got 3x, and then they multiplied it to 2, and they got 6. So now their new equation reads 3x plus 6 is equal to 5x plus 12. So what justifies that? What allows them to change 3 times this sum into the sum of these products? That is the distributive property. That's what they use to get to step 3. So that's the reason for that step. Next, they subtracted 3x from both sides, and they got to this statement. So they're allowed to subtract the same thing from both sides because of the subtraction property of equality. They did it again, but this time they subtracted 12 from both sides. So again, how did you arrive to step 5? You arrived by using the subtraction property of equality. From there, to get to step 6, they divided by positive 2 on both sides. What allows them to divide by 2 on both sides of the equation is the division property of equality. After that, they just flip-flopped it, and they said, because notice it says that the proof statement is x is equal to negative 3. Well, statement 6 is not what the proof statement says. It's similar, but it is not what the proof statement says. So they then had to switch and say that x is equal to negative 3. You're allowed to flip-flop that because of the symmetric property of equality. And you're done. So we get to try that out on our own. Again, come to class with a bunch of questions about this format. And we'll try to clarify everything. Hopefully, trying one of these together will help you understand justifying and giving reasons for each statement. So try these A. Supply the reasons to justify each statement in the proof below. So they gave us all the statements. We just needed to justify why they're allowed to say each one. So let's just take one at a time. And if you want to cover up the rest, that's probably a good idea so you don't get ahead of yourself. Okay, here we go. So we're given the equation x minus 3 divided by 2 is equal to 6 plus x over 5, and our prove statement is x equals 9. So if you notice, our very, very first statement is what we're given. Our very, very last statement is what we're trying to prove. That's our end goal. That's the direction we're heading. So let's start it off. Number 1. The first statement is always what you're given. So reason 1 is given. It'll always be reason 1. Start off with your given. From here, they decided to multiply both sides of the equation by 10. So why am I allowed to multiply both sides of the equation by a number or by some value? That's because of the multiplication property of equality. The next, they took this 10 and then it was being divided by 2 and got 5, and they had 10 divided by 5 and got 2. Some people would say that this is substitution. They are applying the substitution property because 10 divided by 2 is 5, and 10 divided by 5 is 2. Some other people would say this is simplifying. Okay, so we're just simplifying. From there, we've got 5x minus 15 is equal to 12 plus 2x. How did they get here? What did they do? They distributed the 5 and they distributed the 2. They're allowed to do that because the distributive property. Again, please notice that the reason for each statement is what did they do to get there? What justifies how they got there? Item 5 is they went from 5x minus 15 is equal to 12 plus 2x, and then they all of a sudden arrived here that 3x minus 15 is equal to 12. Well, what did they do? Well, they subtracted 2x from both sides. What allows them to subtract 2x from both sides and get to this statement 5? That is the subtraction property of equality. Next thing is that they added 15 on both sides, and they got 3x equals 27. Why are they allowed to add the same thing on both sides of the equation? That's the addition property of equality. And then the last step, they're going to divide by 3 on both sides to get the final answer, x equals 9. How did they get to this x equals 9? Well, they had to divide both sides by 3. So they got here by applying the division property of equality. And there you have it. It says under try these A, part B, it says complete the prove statement and write a 2-column proof for the equation given in item 4. So if we look back to item 4, this is the equation that was given, and we worked it out. What they're asking us to do in part B, it says complete the proof statement. So if we're given this equation, then our end goal is going to be to prove that x is equal to 2, because we know that's the right answer. And then it says number each statement and corresponding reason. So if we go back here, our first statement was writing our original equation. Why are we allowed to do that? Because that was given to us. So we're just going to turn this bad boy into a 2-column proof. Here are my statements over here. Here are my reasons, my justification. So my first statement is what they gave us. It's given. My second statement, how did I get here? What did I do? I subtracted 9 from both sides of the equation, and so I used the subtraction property of equality. The next thing I did is I added 1/2 to both sides, and I got to 9 halves x equals 9. Well, what did I use to get here? I used the addition property of equality because I added 1/2 x to get to this statement 3. Next thing I did was I divided both sides of the equation by 9 halves, and I got to my fourth and final statement, which was that x is equal to 2, which is my proof statement. And what did I do to get here? Well, I divided, and what allows me to divide by the same value on both sides of the equation? That is the division property of equality. That's it. So it's just the first half of this lesson was just getting used to definitions and understanding the importance of undefined and defined terms, and just a good reminder that we need to start with, we started with the basics and we're just going to build up off that. Also a good reminder of our definitions need to make sense to us. You need to use words that you understand. So don't try to sound all prestigious using the biggest words you can find. That's not going to do anyone good. Use words that you understand, and make these definitions, make these terms personal, make them mean something to you. And then the second part was just a great introduction into 2-column proofs. We're already familiar with solving algebra equations, so now we're just going to put it into this format. So come to class ready to do more with 2-column proofs, and also just to understand the structure and how these 2-column proofs work. I'll see you later.